What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about estimating a population proportion. So we're still taking a simple random sample of of population data here. So we're taking a smaller sample of the whole population. So what we found out was that the mean, or the point estimate, the mean is just x divided by n, where x is the number of individuals in the sample divided by their sample size. But we also have to make sure and check to see that the number of individuals in the sample times that particular point estimate times 1 minus that point estimate is still greater than or equal to 10. If it is, then it's approximately normal, then we can continue on. So then we can find the standard deviation, and from there we are going to find an interval of a certain confidence level. So in order for us to find an interval, what we're going to do is we're going to find the mean and then add or subtract some kind of margin, which is called the margin of error. Okay, so the margin of error, E, is finding the z-score of alpha divided by 2 times their standard deviation. Now, with that being said, what we have to look at is, well, the question that you're going to have is, hey, what the heck is alpha divided by 2? Because we've never done that before, right? So let's say, for example, if we're looking at, let's say, 95%, okay? So if we look at 95%, then we're looking at this point, from an interval from here all the way to here, okay? So in other words, we're looking at everything that is in here, right? This area on the curve will be your 95%. Now, with that being said, what do we have left? Well, we know that the area on the curve is 1 or 100%. That means we have left the right tail and the left tail, right? And the two tails, I would say the red shading here, is going to equal to 5%, which is my total alpha. Since it's split in half, that means, again, split in half, that means each tail is going to equal to 2.5%, which in decimal will be 0.025. Okay, so that is the case. Now, remember that your calculator really calculates the left tail. So your calculator is going to give you this number if I put in the calculator with 0.025. Now, if I want this number on this side, it's just going to be the positive of this because, again, if we're normally distributed, then we're going to be symmetrical. So if this is negative 1.96, this will be positive 1.96. And to enter that, it would be 1 minus this alpha divided by 2. Okay? So I know that this looks like a lot, but essentially all we're doing is let's find the margin of error, then we're going to add and subtract from that point estimate. All right? So it looks complicated, but let's do it one step at a time. I'm just trying to throw it all in one just so that it's a little bit easier, or better yet, all in one, so that it looks more complicated, but let's just take smaller bites, okay? And then you have a table here that you can find critical values if you wanted to, right? If you want to refer to this table, you can. However, we do have to understand that we can find this right in our calculator. Okay, so let's say the 95%, I got 1.96, right? So the question is, how the heck did I get 1.96? So to do that, let's see if I can draw this arrow with a parabola looking thing here so that it looks like there we go. All right, so to do that, if we have a TI, what we're going to do is we're going to do a inverse norm of 0.025. Actually, you know what? We'll do 1 minus 0.025 because I want that right tail and not the left tail. Now, we got to use a comma put 0, 1 because we are talking about a normal distribution where the mean would be 0 and the standard deviation would be 1. Now in Desmos, it's going to be a little bit longer. It's going to be the inverse CDF of their normal I'm just going to write in caps because I write better in caps. Normal distribution of 0, 1, parentheses, 1 minus 0.025. Okay, so that this way, either way you put it in, you're going to get this 1.96. Again, if you put in just the 0.025, you're going to get the negative 1.96, but since it's symmetrical, that means we're going to use a positive 1.96. All right, so let's go ahead and head into an example here. So this is an example where it talks about a parent-teen cell phone survey conducted by Princeton, and it's just saying, okay, so what we have here is that we have 800 randomly sampled 16 to 17-year-olds living in the United States were asked if they would use their cell phone while they're driving or text while driving. And out of the 800, 272 indicated that they do text while driving. Okay, so what I want to do is find a 95% confidence interval of the proportion, okay, of the 16 to 17-year-olds. So with that being said, the first thing I want to do is to find p hat. Okay, so let's go ahead and find p hat, or the point estimate, which is x divided by n. Well, the x is going to be the number of individuals, which is 272 that actually text and drive, and then out of how many? Out of 800 people, right? And that's going to give me approximately 0.34. Now, again, this is a proportion, which is about probability, which is going to be less than 1, okay? So anytime we talk about proportion, we're talking about something that's less than 1. So that's the first thing we have to do. Second thing we have to do is to check. So let's check to make sure that this is normally distributed, meaning that n times p times 1 minus p has to be greater than or equal to 10. All right, the n was 800 times 0.34 times 1 minus 0.34, and see if that's greater than or equal to 10. And what you will find when you calculate everything here on the left-hand side is that, yes, it does check out, okay? So it is normally distributed. So the third thing we want to do, since we already have the mean or the point estimate, now we just need to find the error. So that would be step 3. So find margin of error, which is E. So E we found was Z of alpha divided by 2 times what? Times the standard deviation, okay? So instead of just finding standard deviation, let's go ahead and just plug it right in, which is the square root of I like to draw the fraction line first. So we're going to have P times 1 minus P, and these are all hats, divided by N, okay? And since this is a 95% confidence interval, I know that alpha is equal to 0.05, where alpha divided by 2 is going to be 0.025, okay? So if I was to look at the Z of 95%, 0.025, my critical value is 1.96. Again, I can find it in the calculator. So you're welcome to do that. So what I find is that the Z of 0.025 is going to equal to 1.96. So that's what we're going to put in. So the error is equal to 1.96 times the square root of did not want to throw that out. I just wanted to multiply this. So P was 0.34 times 1 minus 0.34 over the 800. Okay. So what you're going to get is approximately 0.033 in this case. Okay. So from there, to find the interval, so 4, the interval is going to be the p hat plus or minus the e. So, which means that my p hat is 0.34 plus or minus 0.033. So I have two answers here. First answer is going to be the 0.34 minus 0.033, and the second answer is going to be 0.34 plus 0.033. So this is going to get me what? This is going to get me a 0.307, and this is going to give me a 0.373. Okay? So with that being said, this is also known as your lower limit or lower bound, and this is known as your upper bound. Okay, so let me go ahead and refine this a little bit, move this in, move these a little bit tighter. Separate these so that we can see our interval. All right. So last but not least, we want to write our conclusion. Which we can say we are 95% confident that the proportion of 16 to 17-year-olds who text and drive is between 0.307 and 0.373, which really mean, because these are proportion, really means like 30.7% to 37% that actually text and drive. Okay, now in terms of showing work, this is what you're supposed to show. So, but in terms of on the exam, when you don't need to, if you don't need to show work, then you can actually find this using just your calculator. So now with the Desmos, you're going to have to go ahead and find your E and then add it and subtract it to your P. For your TI, however, the TI is a little bit easier because then you can do 1 prop Z interval and enter your X, your N, and your confidence level. So in this case, you would do 1 prop z int of, what was my X? My X is 272. My N was 800. And my confidence level was 0.95. And you ought to get the same exact interval. Okay, try that out and see what happens. All right, so next, so here we have the sample size and everything else working out. However, sometimes they're unsure of, hey, what sample size should we use? Okay, so if we were to have to determine the sample size needed, and we know p hat from previous, then we can use this formula here. If we, however, don't know a previous p hat or a previous point estimate, then we would go ahead and do something like this. And we always round that to the next whole number, no matter how low that decimal place is. Okay, so so even if we have like 23.002, we're going to round that to a 24. Okay, always to the next. So anytime we have a decimal, go to the next one. Okay, all right. So let's take a look at this example here. An economist wants to know of the proportion, so we're back to proportions, of the U.S. population who commutes to work via carpooling. What size sample should be obtained if the economist wants to estimate within 2 percentage points? This is my E, which is going to be equaling to 2% or 0.002. Okay? Oh, actually, sorry, 0.02. That's 2%. All right? Of their true proportion with 90% confidence. Okay? So we want 90% confidence. All right? Now, part A says, well, the economist uses the 2009 estimate of 10%. So we're using 10% from 2009. Okay? Obtained from America Community Survey. All right? So what does this tell me? First of all, this part right here tells me, the 90% confidence tells me that alpha, the leftover, will be 10%. So therefore, alpha divided by 2 is equal to 5% or 0.05. Okay? So I should probably, let me see if I can do this. Nope, I cannot. Or 0.05. Okay? So I can find the z of 0.05, and that's going to give me a 1.645. Okay? All right. So how does this all help me? So I already know that E is equal to 0.02. I know that my z of 0.05 is equal to 1.645. All right. Now, so you're wondering, what is this? Right? So what is that? Well, that right there, so let me do this here. Let me put a box right in front here. So you can see that that green arrow is coming from here. And let's use, let's say, a blue box for this one right here. And the blue box is telling me, wow, there we go. The blue box is telling me that the p hat in 2009 is equal to 0.10. Okay, so since I know a past estimate or past p-hat, then we want to use this formula here, right? So in this case, n, the sample size, is equal to p-hat times 1 minus p-hat times p, oh, sorry, not p. This is going to be z of alpha divided by 2 divided by e squared. Okay, so in our case, n is going to equal to 0.1 times 1 minus 0.1 times the z, which is the 1.645, divided by e, which we had up there, which is 0.02 squared. All right, and what you're going to have is that this is approximately 608.85. So we're going to go ahead and round that up to 609. Yeah, it's not going to let me do that. It's all right. So it's going to give me 609 as my answer. So there it is. Okay. All right. So what if the economist does not use a prior estimate? Okay. In that case, then we would want to use this formula here. Okay. So if we don't use a prior, then we use n is equal to 0.25 times z of alpha divided by 2 over e squared. So that's going to equal to 0.25 times, so I'm still using that 1.645 divided by e, which is 0.02 squared. And this n is going to be approximately very large, 169.1.2. So we're going to go ahead and round that to 1,692 for our n. And there you go. Well, I hope that helps. If there's any questions, please let me know. See ya. Bye.